Good day everyone. You are about to watch a video tutorial and a brief discussion about the Enhanced Interior Gateway Routing Protocol. So keep calm and listen. First things first. What is EIGRP? EIGRP stands for the Enhanced Interior Gateway Routing Protocol. It is a network protocol that allows routers to exchange information that is more efficient than the earlier released network protocols. The basic operation of EIGRP. EIGRP stores data in three tables, which is the neighbor table, the topology table, and the routing table. First, let's talk about the neighbor table. The neighbor table stores data about the neighboring routers, those that are directly accessible through directly connected interfaces. In this example, router 1 or the router 1's neighbor table will contain all those information of the routers that are directly connected to router 1. As we can see, router 3, router 4, router 5, router 2 is directly connected to router 1. So their information about this router will go to the neighbor table of router 1. Next comes the topology table. The topology table, confusingly named, this table does not store an overview of the complete network topology. Rather, it effectively contains only the aggregation of the routing tables gathered from all directly connected neighbors. This table contains a list of destination networks in the EIGRP routed network. So, in this example, router 1 will send a data to router 4. So, there is a term called successor and a feasible successor. Successor means the path or the best path or the primary path. So as we can see, router 1 can send the data to router 4 in this path. So this path is the best path. So this path is the successor. Then it will send the data here directly. There is also a term called feasible successor. A feasible successor is a backup path or the next path. If the primary path is down, then this path will be the one to be used by the router. So here in this example, router 1 can also communicate to router 4 by going to router 3 and then to router 4. So this path is this feasible successor. So this is the successor, the best path, and this is the feasible successor, the backup path. If this path or the successor path will fail or will go down, then you can also send a data or a message through the feasible successor or the backup. Then lastly, the routing table. Routing table stores the actual routes to all destinations. The routing table is populated from the topology table with every destination network that has its successor and optionally feasible successor identified. The successors and feasible successors serves as the next hop routers for these destinations. Why choose EIGRP? Well, I do have 4 reasons to choose EIGRP. First, its flexibility and summarization. The network in a EIGRP routed network can be auto-summarized. Next, backup routes. Remember the successor and the feasible successor? EIGRP is the only routing protocol in the world that allows backup routes or that only remembers backup routes. Third, the combination of distance vector and link state. Cisco's goal with EIGRP was not to have a super complex protocol, but they wanted a protocol that could do the same things as OSPF. But the easy, meaning take the easy to configure aspects of distance vector like RIP. RIP was really easy to turn on. Take those features and combine with all the advanced feature of link state and set a simple configuration. Lastly, EIGRP can support multiple networks protocol. It can run separate routing processes for Internet Protocol, IPv6, IPX, and AppleTalk through the use of protocol-dependent modules. EIGRP classification as a distance vector. EIGRP is technically a distance vector routing protocol and relies on routing information from directly connected routers to get information about the topology of the network. While EIGRP is an advanced routing protocol that combines many of the features from both link state and distance vector routing protocol. EIGRP is still a distance vector routing protocol due to the fact that it is based on the diffusing update algorithm, or the DUO. To configure an IP address to a router's interface, you must know the interface type that is being used by the router. So, in this example, router 3 uses two interface types, which is the fast Ethernet 00 and the 000. We will now configure an IP address to the fast Ethernet interface. This is how you do it. First, go to the global config. Then type interface followed by the interface type with its port number, which is the fast Ethernet 00, and press enter. As we can see, the network address of this network is 192.168.100.0. So we can use the possible host 1 to 254. So in this case, we will use the first possible host, which is 1. Type IP address, then the IP address, which is the 192.168.100.1, then the subnet mask, the 255.255.255.0, and press enter. The /24 here in the network address indicates what should be the subnet mask. Now, do not forget that the IP address, this one, will be the default gateway of those devices that are directly connected to the fast Ethernet 00 interface. Now, type no shutdown to turn on the port. Then, lastly, type exit to go back to the global config. The same thing to do in other interfaces. By the way, the default gateway thingy will be only applied to the fast Ethernet interface. To configure EIGRP on a Cisco iOS router, you must know the syntax of it. So this is the syntax. So you should take note of this. Then now the router EIGRP AS number can be any number. But always remember that once you have chosen a number for your AS number, the autonomous system number, you must memorize it, because this number must be the same with the other autonomous system number in this other router. So next will be the network, then the network address, and the wildcard mask or wildcard bits. Then no auto summary, so that the network will not be summarized. Then end to exit. So let's try to configure router 0. So first, you must go to the global config. So enable configure terminal. Then we must first see the routing table. So do show IP route. This is the command for showing the routing table. So these are those networks that are directly connected to router 0. So okay, see this thing, see this one. So we must type this one. Okay, so router here, router EIGRP, then the AS number. So the AS number, I will assign 1 or no 3. I will assign 3. Then press enter. Network, then this one 192.168.1.1.0, then followed by the wildcard mask. The wildcard mask is the opposite of the subnet mask. So it is /30. So the subnet mask is 255.255.255.252. So to make it the wildcard mask, you must minus it. This number must be minus 255.255.255.255. So the thing is 255 minus 255 is 0. Oh no. 255 minus 255 is 0. Here one 255 minus 255 is 0. 255 minus 255 is 0. Then 255 minus 252 is 3. So 3. So then enter. So this is the wildcard mask of this network. So next, the next network, which is router network 192.168.1.8, then followed by the subnet mask. It is also /30, so the same as the first one. So 0.0.0.3, and enter. If you don't want if you don't want that the network will be auto summarized, then you should enter the command no auto summary, then exit, so that you should go you will go back to the global config. Exit. Oh, we forgot we forgot this network. So let's go back to router EIGRP 3, then direct network, this network 192.168.100.0, the /24. See the /24. So if this is the wildcard mask, if this is the subnet mask, then you will minus it to 255.255.255.255. So 255 minus 255, it is 0, right? So this one 0, then the other one 2550 and 2550. So here 255 minus 0 is 255, so 255. Enter. Then again, no auto summary, or no auto summary, then exit. So that's it. Then close this one and go. Let's go to router 1. Okay. So now let's configure router 1. So let's go first to the global config. So configure terminal. So now we're on the configure terminal. So still we will show the routing table. So do show IP route. So these 3 are so again this tree here, this directly connected. So here, so in router 1, if we will do the EIGRP, the router will advertise that this network is directly connected to him. So he says 192.168.1.4, I have it. So he will put it on the routing table. So he will say that 1.4 and 1.8 and 200.0 is accessible through him, through this router. So let's do it, so that he can advertise Okay, so router EIGRP, the same autonomous system as the router 0, so 3. Then network, this one, network 192.168.1.4. Then the wildcard, the minus 255.255.255.255. So it is slash 30. So it's 252. So it's 0.0.0.3 because it's 255.255.255.252 minus 255.255.255.255. So this is the result. So press enter. Then next network 192.168.1.8, same as this is the same slash 30, so 0.0.0.3. So next this one network 192.168.200.0, it's slash 24, so 255.255.255 minus 255.255.255.0, so it's 0.0.0.255. So enter. Then no auto summary, so that the network will not be summarized. Okay, these prompts is a new adjacency, so there is change in the topology table. Next, so let's exit so that we can go back to the global configuration. Then in the last router, finally the last router, so router 2. So let's exit, so let's go to the global config, so configure terminal. So here we're not on the global to let's check do show IP route, so that it will show the routing table. So let's start router EIGRP, the autonomous system number is 3. It's the same with the other router. So then the network, this network, so 192.168.1.0 slash 30, so 0.0.0.3. Next, new adjacency I've made, so network 192.168.1. Oh my god, mistake. 1.4, then 0. Many mistake. 0.0.3. It's still slash 30. Then lastly, the network 168.150.0, it's slash 24, so 0.0.0.255. Then no auto summary to avoid summarization. Then exit. So okay, let's go to router 0. Let's check if we have successfully configured EIGRP. So let's go again to the here show IP route. So this D means that it is configured as EIGRP. So these are configured EIGRP. So we successfully configured EIGRP. So let's see the do show IP EIGRP topology to check the topology table. See, this is the topology table. So it has one successor. If two successor, then the other successor is the visible successor. The next, let's show the neighbor table. So show IP EIGRP neighbor. So this is the neighbor of router 0, the 10 and the 2. That's it. So we successfully configured router 0 as an EIGRP network, routed network. Check the router 1. So show show IP route. Still it is D, so successful. Then lastly, router 2, do show IP route. So we have successfully configured a EIGRP routed network. So wow, clap your hands. Actually, there's another way to check if the configuration works. So let's go to this PC and open its desktop command prompt. So we will try to reach this network. So we're in this network, we will try to this network. So ping 192.168.150.0. So as we can see, it's replies. So we can reach that network. How about this network? So ping 192.168.100.0. Still it replies, and so it's clearly that it is been successfully configured in an EIGRP routed network. So it's successful. So that's it.